Hello everyone, this is Dennis and you are on the Den Lecture channel. Today I want to talk about the concept of voltage drop across a diode. Everyone knows from the school physics course that diodes have different voltage drops. All these figures are very average and are taken only so that you can sleep peacefully. In fact, everything is much more complicated. The voltage drop across the diode depends on the current passing through it. The higher the current, the greater the voltage drop. Let's figure out if this is a good thing or a bad thing. The voltage drop itself cannot be attributed to a bad or good property of diodes. In some cases, it helps to extinguish excess voltage, from several hundred millivolts if conventional diodes are used, up to several dozen volts if you take Zener diodes. This property of diodes is also very often used as a reference voltage. In other cases, when we use diodes as rectifiers, this property of diodes brings some problems. With a large voltage drop and high current, the diodes heat up very much. Let's do a test on S30SC4M dual Schottky diodes. It is designed for 40 volts and 30 amps, but each of the diodes can withstand only 15 amps. I will only check one diode. If the multimeter has a diode test function, then it is very easy to measure the voltage drop. I apply the negative probe of the multimeter to the cathode and the positive probe to the anode. It only shows 96 millivolts. However, this will only be the initial tension, the voltage drop that occurs at about a current of 10 milliamperes. To find out how a diode behaves at high currents, you need to assemble a small circuit. Off-screen, I connected the load. Current will be supplied to it through a diode. This multimeter will show the current through the load, and this one shows the voltage drop across the diode. Don't pay any attention to these diodes yet, we'll come to them later. First, I will set the current to 1 ampere. The voltage drop was 306 millivolts. I increase the current further. I will set 2 amperes. The voltage drop becomes more than 330 millivolts. With a current of 3 amperes, the drop is 345 millivolts. At 4 amperes, 357 millivolts. And at 5 amps, 368 millivolts. From this experience, it becomes clear that the more current flows through the diode, the greater the voltage drop becomes on it. To find out what the voltage drop will be on this diode at its maximum of 15 amps, it is not necessary to take your measurements and load up to 15 amps. This information can be found in the documentation for this diode assembly. There is a graph with a voltage characteristic. It can be used to find out what voltage will drop on the diode when a certain current passes. Let's explain how to find out. The horizontal voltage drop is indicated, and the vertical current passing through the diode. 2 dotted lines indicate a voltage drop at a temperature of 150 degrees, and 2 solid lines indicate a voltage drop at a temperature of 25 degrees. There are 2 values for each temperature, typical and maximum. This is due to the fact that there are no 2 identical diodes. They can always have a discrepancy in parameters. You can find out the voltage drop at a certain current as follows. Let's say I'm interested in a current of 1 ampere. First, I find this mark on the horizontal line. I follow it until it meets the black line. From the place where they intersect, I draw an imaginary vertical line and go down. This is where the approximate voltage drop across the diode will be. If you look at the left lane, by the typical value. With the current of 1 ampere, the voltage drop should be slightly more than 0.3 volts, about 325 millivolts. If I'm interested in a current of 2 amps, then I'm looking higher. Here, the voltage drop will be approximately 360 millivolts. I also traced all the other currents and compared them with my measurements. My readings turned out to be about 10% less than those indicated in the bill. They turned out to be less than not only the maximum, but also the typical ones. Most likely, this is due to inaccurate measuring devices, a voltmeter and an ammeter. In addition, the diode assembly may be a fake, or it may be manufactured in violation of manufacturing technology. Well, my last theory is related to the temperature at which the measurements were made. Pay attention to the chart. At a temperature of 150 degrees, the voltage drop across the diodes is almost 2 times less than at a temperature of 25 degrees. When current is passed through the diode, it naturally begins to heat up, even if it is on the radiator. Because of this, measurements may differ even with accurate measuring instruments. In general, all these nuances affect the measurements. And therefore, when you look at datasheet on your diode, you do not need to look for exact matches with your readings there. Let's go back to the dashboard and look at the top of the graph. We want to find out what losses we will have at maximum current. At a current of 14 amperes, a voltage of 0.8 volts will drop on the diode. That's quite a lot. 8 times the initial voltage drop, and 2.5 times more than at a current of 1 ampere. But with a current of 10 amps, it's still pretty tolerable. The drop is only 0.5 volts. Different diodes, even if they are all Schottky diodes, may also have different voltage drops. My measurements are recorded here. They also don't match up with the startups a bit. These are the diodes that I've been checking now. This is a single 100 volt 5 amp diode. And these are double diodes for 200 volts and 20 amps again. One diode naturally holds only 10 amps. From all this, it can be assumed that the higher the operating current of the diode, the lower its voltage drop. But at the same time, its maximum operating voltage decreases. If the voltage of the power supply is 5 to 10 volts, then you can use the first option. Even if the current consumption is only 2 amps, we can save twice as much energy and reduce heat generation. If the voltage of the power supply is higher, then you will have to take other diodes, but there will most likely be a greater voltage drop. On silicon diodes, the drop is even greater. Let's look at the Soviet 2D213A diode. It can withstand a voltage of 200 volts and a current of 10 amps. This is what his test results look like. Compared to its closest counterparts, the Schottky diode, the voltage drop here is greater from 70 to 100 millivolts, but at maximum current, everything is very deplorable. Judging by the chart of the start, at a current of 10 amps, the voltage drop will be even 1 volt, while on MBR20100CT diodes at 10 amps, the voltage drop will be only 750 millivolts. Since in this video I'm talking about the voltage drop on the diodes, I want to add a little bit about what kind of thermal power is released on them. Take for example the latest diode 2D213. At a current of 10 amps, 1 volt of voltage drops on it. If we multiply these numbers, we get 10 watts of heat output. But this is only under the condition that the current through it is constant. If we rectify alternating current in the form of a sine wave or a meander, then the diode will cool down in the intervals between half cycles. Therefore, the heat output on it will not be 10 watts, but half as much. That's all for today. Please like, subscribe to the channel, and bye-bye.